So today we're going to talk about SOH, but before we talk about SOH, we should probably review what all this stuff means. So remember, in a right triangle, well, in any triangle, but particularly a right triangle, we give a title to each of the three legs. So this is my 90-degree angle, and the side across from it we call the hypotenuse. So we just put an H there for hypotenuse. Now if I have some angle X, the side across from the angle X we call the opposite. And then the one that's touching the X that isn't the hypotenuse, we call that the adjacent. So OH and A are what we're using for hypotenuse, opposite, and adjacent. Now SOH helps us to remember the three trig functions. These are the three main ones. Sine of X is nothing more than the comparing of the opposite side over the hypotenuse. Cosine of X is equal to the adjacent side over the hypotenuse. So whatever length it is, and we'll do some examples, we compare the adjacent over the hypotenuse. Tangent, what we did last time, of X is the opposite over the adjacent. Okay? So let's review tangent, and then we'll get started on sine and cosine. So I've got a right angle triangle, alright, and it's not drawn to scale, but let's assume that this is 3, this is 4, and these are our Pythagorean triplets, so, or triples. What should this one be? 3, 4, 5, right? And we know that would be true because if we took the Pythagorean theorem, that's what we would get. So I've got two angles. Let's label this. Let's call this C, call this A and B. And let's say I want to know the sine of A. Okay. And I want to know the cosine of A. Well, the sine of A is kind of, well, it's simple. The sine of A is just the opposite over the hypotenuse. TOA, SOH. Well, what's the opposite of A? Well, the opposite of A, you start at the angle A and you go the opposite of it, which is 4. Well, what's the hypotenuse of A? Well, let me tell you something. The hypotenuse of any angle is always going to be the hypotenuse. So that's going to be 5. That's never going to change no matter what. Now, when we do the cosine of A, that's the adjacent over the hypotenuse. And so the adjacent is the one that's touching A that isn't the hypotenuse. So that would be 3 over 5. Alright? So I want you guys, and I'm going to write real slow, I want you to find the sine and cosine of B. And I'll be quiet and give you some time to do that. Alright, I see some pencils dropping. That's a good question. So let's do it. The question was what's adjacent from B? Is it, I guess what he's questioning is adjacent the same for B as it is for A? Let's look. Let's do sine first. The opposite of angle B. Well, we go to angle B. What's the opposite side of B? It's 3, because 3 is across from it. What's the hypotenuse? 5. Alright. What is the cosine of B? Well, what's the adjacent of B? 4. What's the hypotenuse? 5. Alright. Now, here's a tricky one. what's the tangent of A and what's the tangent of B? Keeping in mind that the tangent is the opposite over the adjacent in both cases, but it's with respect to the angle that we're using. Well, let's start with angle A. What's the opposite of A? We start at A, we come down, go across, it is 4. What's the adjacent of A? 3. Alright, now what's the opposite of B? 3, because I go across here. What's the adjacent of A? Or I mean B, I'm sorry. 4. Okay. Any questions? No? Alright, let's do an example. So, for example, let's draw a 90-degree angle, triangle. I'm so glad that you guys know how to speak, Mr. Adams. Sometimes I say the wrong thing and write the right thing down, and you guys are smart enough to figure that out. So I've got, same with my handwriting. I've got a right triangle, RST, and I want to know the sine of S and the sine of R. Well, the sine of S is the opposite over the hypotenuse. Remember SOH, CAH, TOA. And the opposite of S is what? Well, let's see. We go to the angle S and we go across from it. 63. Now, the hypotenuse is the side length that goes across from the 90-degree angle or the right angle, so it would be 65. Now, sine of R, we go from angle R, that's still going to be the opposite over the hypotenuse, but the opposite of R is 16, and the hypotenuse is still 65. Okay? So far, so good. Alright. Let's draw another right angle triangle for another example. Alright, so let's find the cosine of U, and then, of course, the cosine of W. Well, let's say Mr. Adams totally forgot all of his trig functions and couldn't remember what was what. So I write down SOH because I remember that Mr. Adams told this amazing story about Chief SOH. And I write out SOH, and I know that this is cosine, and cosine of an angle is the adjacent over the hypotenuse, so I write A over H. I go to U, and I look and I say, which one is the adjacent of U? So I go here at U, and I say, what's adjacent? Adjacent means touching. Well, informally, that's what we're going to say. That's how we remember. Which one's touching? 30 and 18. What's the adjacent? See, I asked that question on purpose. 30 does touch it, but it's across from the right angle, so what's 30? The hypotenuse. So which one's the adjacent again? 18, because 24 is the opposite, because it's opposite you. So only one left is 18. Well, the hypotenuse is 30, as we all kind of said. Now, I could reduce this by dividing the top and bottom by 6, so that would give me 3 over 5. And that's a good answer, but, let's try. We're going to get in the habit of writing these down. Remember, we said that those are numbers, and we want the decimal of it. So if I say, first of all, let's try something. 18 divided by 30, right? Equals 0.6. Well, if I reduced it right, 3 divided by 5 should also equal 0.6. So you don't have to reduce the fraction if you're just going to put it in decimal form. And you'll know when to put it in decimal form. Alright, so let's find the cosine of W. The cosine of W is the same thing, the adjacent of W over the hypotenuse. Well, what's the adjacent of W? We go to W, and the adjacent is 24, so it's 24 over 30. Now, I could reduce that by dividing the top and bottom by 6, but let's just find the decimal. In your book and in your note-taking guide, they're going to want you, or they're going to show you, and I'd like for you to write it out because you need the practice. But when you take the ACT, you don't have time to do all these extra steps, so it's kind of good to skip a step once in a while. Yes? Oh, yeah. Okay, hold on a second. So this is going to be the actual value of 8. Now, I made a mistake last time. Can you guys look at this first one and tell me what the simple little mistake is that I made? It's not a big deal. I'll tell you. Normally, if I take a decimal from a fraction and we round it, we will put these little squiggly equal signs. But 3 divided by 5 is an actual 0.6. Okay. It's actually 0.6. So we say that it equals 0.6. Alright. So this one right here actually reduces down to 0.8. So the cosine of W is 0.8. Alright. So now let's do a real problem, okay? When am I going to use this in the real world stuff, right? How about today? How about on your final? I know, I'm a funny guy. I know you can't see it. I'm working on it. Alright, so for this example, let's assume that this is a house. Okay, so let's assume, I'm going to try and draw a picture as best I can, but let's assume that this is a house, and this is the roof of the house, and this is a fancy looking house. Well, it's the best I could do, but let's say that this is the roof of a house. Alright. What do I look like, an architect? A bird's eye view. Yeah, draw the house. Yes, this is, and here are some bushes in the yard. This is we're looking up from the top.
Yeah, bird's eye view, what I just said.
Yes, it's a bird's eye view. This is 35 degrees. Alright, and there's some bushes. Here's a big tree in the yard. And what we want to do is there's a little dog. Now, I'm not really good at drawing dogs. You leave my dog alone. So there's a dog, and I've got an eye hook on this end of the roof and the eye hook on this end of the roof. And what I want to do is you ever seen those things where they take the leash of a dog and they attach it to a line and the dog runs up and down the line? All right, that's what I want to do, and I need to figure out how long this line is. So I'm going to say that the line, since I don't know what it is, I'm going to call it X. Okay? But I do happen to know that the length of this wall is 11 feet. Okay? So I want to solve for X. This is kind of like the tangent problems we did. And so to solve for X, I've got to label some things. So here's my angle 30. What is 11 with respect to the 35-degree angle? It's the opposite. So I'm going to say right here that 11 is my opposite. Now look at X. What is that with respect to the angle 35 degrees? What part of the triangle? That's the adjacent? Uh-oh, we're changing our story. Yeah, you're right. You're smart to change your story. This is the 90-degree angle. X is across from the 90-degree angle, so it is in fact the hypotenuse. Now let's look at our SOH. We have SOH, TOA. Man, that was a good story. Tell the truth, you guys went home and posted it on Facebook. Yes? Text your friends. All right, settle down, settle down. I shouldn't have got you all worked up. Shh. So anyways, look at this. I've got the opposite and the hypotenuse. Which one of these trig functions deals with it? Sine does. Sine does. So I say sine of what? 35 degrees is equal to the opposite over the hypotenuse. Or, yep, sine of 35 degrees is equal to 11 over x. Well, we know that sine of 5 can be a number, so let's plug that in. Sine of 35 that equals 0.57. Let's just say 0.6. You should probably carry it out more, but I'm really more concerned with you guys being able to get it set up and get close. Alright, so now what we're going to do, to solve this, you could do some fancy algebra, but let's make it simple. Let's put this over 1. That gives me a proportion. How do I solve my proportion? I cross multiply. So when I cross multiply my proportion, I get 11 times 1, which is 11, is equal to 0.6 times x. What do I do to get x by itself? Divide by what, 11? 0.6, very good. Because that's what I want to move away. So when I do that, I end up with 11 divided by 0.6, which is 18.3 repeating. Right? 18.3 repeating. So I'm going to say 18.3 repeating. Now, because I'm saying I rounded it off, I use my squiggly line, right? Well, actually, that's the exact value. Let's just say 18.3 with the squiggly line. Now, does that make sense? What if that would have been 8.3 repeating? Let's look at our picture. Could that have been 8 feet? How come? Because the hypotenuse is the longest side, and it has to be at least longer than 11, right? Okay, good, good, good. You guys are doing excellent. I think we're going to do one more example, and then you can do your note-taking guide. I can't do a shout-out on the thing. I'm not doing a shout-out. Don't make me get irate. All right, who's the skateboarder in here? All right. Okay.
I'm
Oh, Lord. Be quiet. I don't care anymore. So, I didn't realize what I was asking. So, anyways, all right. Okay, here's my little skateboarder dude. That's his hat. All right. So here's the ramp, and for some reason this kid wants to know, yeah, why's it got to be a boy? Maybe it could be a girl. All right. So, anyways, she's for some reason she wants to know how high and how long the ramp is. Maybe she wants to build one for at home. She's at the skate park. She wants to find out how big to make this thing. The only thing she knows is that with a tape measure, she can actually measure 14 feet on the ramp itself. And she remember talking to the guy that like took care of the park, and he said, yeah, it's a 26-degree incline. Okay, so she goes, man, I want to build a ramp like that at home. How do I do it? Well, let's talk about that. 14 is what? The hypotenuse. Why? Because it's across from the 90-degree angle. X is what with respect to the 26-degree angle? It's the opposite. And Y is adjacent. So we're going to remember SOH TOA. All right, so I want to find X first. So to find X, I need the opposite, and you're going to need a number or you won't be able to do it. So you've got the number, which is the hypotenuse. So hypotenuse and opposite is what I need. Which trig function do I use? Sine. So I would say sine of what? 26 degrees is equal to the opposite, right? Opposite over the hypotenuse. What's the opposite? X over 14. All right. Now, we could use the proportion thing. Should I do that? Yeah. Let's just use the proportion thing. We're going to stick to it. And I could cross multiply. Well, before I do that, let's find out what sine of 26 is. It'll just take a second for everything to the light. You couldn't see the calculator. So anyways, sine of 26 is equal to 0.438 roughly. So I'm going to say 0.44. So I'm going to say 0.44 over 1 is equal to x over 14. Cross multiply. Hey, slow down, Speedy. Let me do it. 0.44 times 14. So when I plug that in the calculator, I say 0.44 times 14 equals 6.16. Okay? Now I did, you know what? I did round off from the calculator, so we should technically use the squiggly equals. 6.16. Now that's just x. Are we done? No, we still need to know y. So y, let's go back and look at the picture. Y is the adjacent. So to do the adjacent, and you could use tangent, but I feel more comfortable using the numbers that the book gives us. Because what if I made a mistake here? Yeah, I know what the opposite is. X is the opposite. But what if I made a mistake here? Well, yeah, Mr. Adams doesn't make mistakes. But what if I did? I want to go with the hypotenuse because that was given to me. So I'm going to say cosine. And the reason that I'm going with cosine is because I get to use the adjacent, which is what I'm solving for, and the hypotenuse, which I know what that number is. So I'm going to say the adjacent, which is y, over 14. Well, the cosine of 26, let's plug it in there. We say cosine of 26 is 0.9 roughly, okay? So we're going to say 0.9 is equal to y over 14. I'm going to cross multiply, and I get 14 times 0.9 is equal to y times 0.9. So that's equal to 12 point, or whoops, I wrote it down wrong. It's not really equal to either, so let's write it down. Let's say y is approximately 12.6. Okay. What did the decimals ever do to you? I don't really care what they did. Alright guys, go ahead and get to work on your note-taking guide for 7.6.